.NET includes an interface named the iClonable interface. We could use that. It enables us to provide a customized implementation that creates a copy of an existing object. The iClonable interface contains one member, the clone method, which we could implement. So why not use that? Well, we could, but there are a few disadvantages. 1. The iClonable interface simply requires that your implementation of the clone method returns a copy of the current object instance. It doesn't specify whether the cloning operation performs a deep copy, a shallow copy, or something in between. 2. It also doesn't require all property values of the original instance to be copied to the new instance. And 3. It returns an object, which would mean the client could need an additional cast. So you can indeed use it, but I would advise not to. This pattern is useful when a system should be independent of how its objects are created and to avoid building a set of factories that mimic the class hierarchy. For example, class A deriving from class B, deriving from class C, potentially with all of them having properties of type class D, E, or F. Creating such a hierarchy with factories would lead to a lot of boilerplate code, which is to be avoided. Another good use case is when a system should be independent of how its objects are created, and when instances of a class can have one of only a few different combinations of states. In those cases, starting from a clone will often be more convenient than starting from an instance with default values. Let's have a look at the pattern consequences. Much of the consequences are related to the abstract factory and builder consequences. Prototype hides the concrete product classes from the client, which reduces what the client needs to know. It doesn't need to know about the concrete classes of the objects of which you want a copy. A positive prototype-specific consequence is reduced subclassing. Instead of having to create a factory method to make a new object, you can simply clone an existing one. A potential liability is that each implementation of the prototype base class must implement its own clone method, which might not always be convenient. Let's have a look at the related patterns. Prototype and abstract factory can be used together. A factory might store a set of prototypes from which it clones when a new instance is requested. There's also a relation to another creational pattern, the factory method pattern. Prototypes don't require subclassing creators. They are not based on inheritance, which is a plus when you favor composition over inheritance, like the Gang of Four. However, they often require an initialize operation on the product class, which the factory method doesn't. Factory method is based on inheritance, but as said, doesn't require that initialization step. Prototype can also be implemented as a singleton, which means it's related to that pattern. Lastly, when using the composite and decorator patterns, both structural, the prototype can be beneficial for convenient object creation. Let's have a look at this module's summary. In this module, we covered the prototype pattern. Its intent is to specify the kinds of objects to create using a prototypical instance, and create new objects by copying this prototype. It essentially describes how to clone. As far as the implementation is concerned, it's important to remember that subclasses of prototype implement the clone method, and clients work on the prototype. There's two types of clones, a shallow and a deep clone or copy. A shallow copy is a copy of primitive type values. So strings, integers and so on will be copied. These are independent of the original object. But complex types that might be properties of the object you're cloning will be shared across the different clones. A deep copy, on the other hand, also results in copies of complex types. And that's it for the creational patterns. On to the next category, structural patterns, starting with the adapter pattern.